Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the photodiode. Now, as the name suggests, photodiode is a PN junction diode which is not very heavily doped. It is a mild doped PN junction diode, and photodiode is used in reverse biasing. And the function of photodiode is to detect any change in the intensity of light, or we can say that it acts as a sensor of light. So this is photodiode. I'll explain the detailed functioning of photodiode in this video. Now, if let us imagine a scenario in which there is a room in which, due to unrestricted uses of electricity, the electricity bill is very high in that house. So we have installed a device which is called a sensor, which is installed in the entrance gate of each room, which will switch on the lights only when somebody will enter the room, and which will switch off the light only when somebody will leave that room. Okay, so this type of device, which can trigger any circuit on the change in intensity of light, is called as sensor, and photodiode can be used for this purpose. So this is a basic explanation of that what is photodiode. So I'm not going into the detail of that sensor. So photodiode can produce any significant amount of change in the current flowing in the circuit when the intensity of light falling on it changes. So this is photodiode, and this is the symbol of photodiode, in which these two arrow represents the light intensity falling on the diode. Now, although we know that photodiode can be used in forward biasing, but we prefer the photodiode to be used in reverse biasing. I'll tell you why. Because in forward biasing, if we draw the forward characteristics, so you can see that in forward biasing, the resistance of diode is very low, and therefore the change in the current flowing through the diode is also due to the change in voltage. So any small change in voltage will result in a significant amount of change in current flowing through the diode. And obviously we know that if some light is incident on the diode, then current will also change. I'll tell you why later on in this video. But let us assume that on increasing the intensity of light falling on the diode, the current flowing through the diode increases. Now, in forward biasing, due to low resistance, current is increasing due to two factors. One factor is change in voltage, and the other factor is change in intensity of light. So we just have to trigger the diode only by changing the intensity of light and not by changing the voltage. So by changing the intensity of light, the current change cannot be determined, because current is changing due to these two factors. So the amount of change in current, which is only due to the intensity of light, could not be determined in forward biasing, or it could not be distinguished in the forward biasing. Therefore, we do not prefer to use the photodiode in forward biasing. But in reverse biasing, we know that in reverse biasing, the photodiode or any diode is saturated, which means that the current flowing through the diode is very small and it is almost saturated. Now, word saturated means that current is independent of the applied reverse voltage. So if current is not dependent on the applied reverse voltage, then any change in the amount of current or reverse current, or we can say that any change in the reverse saturation current, is only due to the change in the intensity of light which is falling on the diode. So therefore we can say that in reverse biasing, in reverse saturation region, the current is independent of the applied voltage, and any change in the current is only due to the change in intensity of light falling on the diode. So therefore we will prefer the photodiode, to be used in reverse biasing. Now let us discuss the functioning of diode, photodiode. Now this is a basic diagram of photodiode connected in reverse biasing. You can see that P side is connected with negative terminal of the battery and N side is connected with the positive terminal of the battery. So this is a reverse biasing arrangement, and obviously the current is flowing like that. This is reverse saturation current. Now we know that when no light is falling on the diode, then also some of the current is flowing through the diode, and this current is called as dark current. This is dark current. Now this is referred as dark current due to the fact that when no light is falling on the diode, then also this current is flowing. Now if we will increase the intensity, now if we will incident some of the light photon on the depletion region of the diode, so these photons should have the minimum energy which is greater than the forbidden energy gap of the base material of the diode. So let us assume that if this diode is formed by silicon as a base material, and we know that for silicon the forbidden energy gap is 1.1 eV. So we should always remember that the photons which are made to fall on the depletion region of this diode should have a energy which is greater than 1.1 eV. Okay, then only the electron hole pairs will be formed in the depletion region, and those electron hole pairs will be, now you can see that the electric field, barrier electric field is like that, and the external electric field which we have applied by this battery is also in the reverse direction. So the number of electron hole pairs which are generated in the depletion region are separated, which means that the holes are pushed towards P side and electrons are pushed towards N side. Okay, like that. So the current will flow, and obviously we know that the electrons which are in the minority carriers in this region and the holes which are in minority carriers in this region are pulled towards the junction. So a minority current will flow in the junction, and obviously this minority current will be or we can also say that this complete diode is illuminated with some eligible photons which are having the energy which is greater than the forbidden energy gap, and all the electron hole pair which are formed in this complete diode are minority charge carriers in P side, which are electrons, and holes are minority carriers in the N side. Those electrons and holes flow according to the electric field, and a current is formed. So we know that obviously due to the fact that the in reverse biasing, the current flowing through the diode is very low due to high resistance, and it is almost saturated. But as we will illuminate the diode with the eligible photons, then more and more electron hole pairs will be formed in the diode, due to which more amount of current will be flowing through the diode. So as we will increase the intensity of the diode, so intensity of radiation falling on the diode. Now what do we mean by intensity of radiation? So obviously we know that intensity of light is equal to photon flux phi into h nu. Now photon flux is, this is photon flux, and we have already studied about the photon flux in modern physics in photoelectric effect, but let me again tell you that photon flux is the number of photons incident per unit area per unit time on the diode. So if we are increasing the intensity of the diode or intensity of the radiation falling on the diode, so we are not changing that radiation, which means that the frequency of the radiation is constant, but we are increasing the number of photons of that radiation falling per unit area per unit time. So if we are increasing the number of photons of that radiation falling per unit area per unit time, which we can also refer as intensity in this case, so we are increasing the number of photons, and obviously the number of electron hole pairs formed in the diode will be increasing, and obviously the reverse saturation current will be increasing. So in this way, let us suppose that if we are using the diode as a sensor, and this is 3 microampere current, this current is 3 microampere. I'm not using the negative sign because I know that this is reverse current, so I'm referring it as reverse current. If this is 3 microampere current, then obviously we can say that the circuit will trigger at this current. So when we will increase the intensity of light to this level I2, then circuit will trigger, and below this intensity circuit will not trigger. So this diode, this photodiode can trigger the circuit by increasing the intensity of light which is falling on the diode. So this is the photodiode, and there is no analytical analysis of this photodiode. It is just a simple reverse biased p-n junction diode which is having a mild doping, not very heavily doped. Okay, so this is obviously due to the fact that due to heavy doping, the Zener reverse breakdown region will reach very soon, and we do not want that reverse breakdown region should reach in this case in photodiode. So we need to operate this diode in reverse saturation mode, and therefore by keeping the doping concentration mild, not very heavy, we increase the depletion region width, and we increase the value of reverse saturation voltage. Thank you.